Hello friends, I'm Patrick. I'd like to invite you on a magical journey through math. With my friends, Mason and Elisa, prepare for your minds to be blown.
Here we have a typical rate function pertaining to debt. Our variables are P for the original amount of debt, R for the annual interest rate on the debt, and K for the amount paid towards the debt per year. For Part A, if a student graduates with $90,000 of student loans debt, how long will it take them to pay it off if they are charged 5% annual interest and make payments of $100 per month? For this, K will be $1,200, R 0.05, and P will be $90,000. For the work for Part A, I will first simplify as much as possible. For this, 1,200 divided by 0.05 will become 24,000 in both points. The next step, I will subtract 24,000 from both sides to get E by itself, as well as subtract 90,000 from 24,000. In the next step, I will distribute the negative into the negative 66,000 to get a positive 66,000. To continue to get E by itself, I will then divide both sides by 66,000. This means I will divide negative 24,000 by 66,000 as well. In the next step though, we must stop because the value inside the natural log to get the exponent of E by itself is negative, and this can't happen. Part A cannot be solved. This is due to the fact that no natural log can contain a negative value. The reason this function does not work is because only paying $100 per month is not enough to pay off the debt, as the exponential interest rate will continue to cause it to grow quicker than the payoffs can decrease it.
Now on to B, which contains two parts. For the first part, we are asked if the same student wanted to pay off all of their student debt in 25 years, what would their minimum payment need to be per month? To begin, we identify the values that we know. P equals $90,000, R equals 0.05, K is unknown, and T equals 25. Now we input these values into the formula. And we have A of 25 equals K divided by 0.05 minus, within the parentheses, K divided by 0.05 minus 90,000 times E raised to the power of 0.05 times 25. First, we simplify the E and its power, which becomes 3.5. Now distribute 3.5 into both values inside the parentheses. Then also distributing the minus sign into both values inside the parentheses. Now we can combine like terms with the K value in it and add that outcome to the other side of the equal sign. Since we need to solve for K, let's divide both sides by 2.5. We have a K value of 6,300, but we are not done yet. Because the K value is originally specified in years, we are asked for the K value per month. Therefore, we need to divide this K value by 12 to get our new K value. For Part 1, the monthly payments will be $525. Part 2 asks the same question, but instead, what would their monthly payments be if they wanted to pay off all of their student debt in 10 years? We set it up the exact same way, except putting in 10 for the T value. It is worked out the same way and gives us a K value of 12,000. Again, we will divide this value by 12 and get a new K value of 1,000. This means in order to pay off all of your debt within 10 years, you will need to make monthly payments of $1,000. Part B tells us that if you want to pay off your total debt in the quickest amount of time, you will be paying larger monthly payments. On the other hand, if you want smaller monthly payments, then you will take longer the amount of time to pay off the entire amount of debt. These are the lowest monthly payments that you can pay to be able to pay it off in the given amount.
Okay, so now we're on Part C. Part C has two parts. It's asking how much will the student end up paying in total for the loan if they take 25 years to pay it off, and if they take 10 years to pay it off. For the first part, you take the minimum monthly payment that was originally found in Part B, multiply the monthly payment you got for 25 years by 12 months to get back into years. Then multiply the 25 years to get the total amount you will pay for 25 years. Now on the second part, you set it up just like the first part, except you use the monthly payment for 10 years again. Now multiply by 12 months to get into years, and now multiply by 10 to find the total amount for 10 years. So if you look at the two values together, it translates to this. If you have $90,000 with 5% interest, you should take the higher payment for a shorter time period because you will pay less money, which is $120,000 compared to paying $157,500.
Boom, your mind is now blown.